Check this out. This is pretty crazy. Right here we have a triangle and a point that lies on one of its sides. Here's what we're going to do. We're going to draw a Cevian, a segment that goes from a vertex to a point on the opposite side right there. Next, we're going to plot a point right there that is the circumcenter of the white triangle. That is the center of the circle that passes through the three vertices of that white triangle right there. See what I mean? Next, we're going to find the circumcenter of the gray triangle. And we're going to plot it, and we're going to show that it goes through those 3 points right there. Last but not least, we're going to find the circumcenter of the entire triangle, that big white one, right? And we're going to plot it. We're going to draw it right there. See how those 3 vertices of the original triangle, that circle passes through all 3 of those. So those 3 orange points are called circumcenters. Watch this. This is pretty crazy. It turns out if you do that, let's hide those circumcircles right there. Those 3 points all lie in a circle. Well, any 3 points that are not collinear always lie in a circle. But it turns out that the circle that passes through those 3 orange circumcenters also passes through the vertex of the triangle through which the original Cevian was drawn. Believe it or not. Pretty crazy. Look at this, right? Doesn't matter where I put that point on the side of the triangle there, as long as I draw that Cevian right there, those 4 points will always be concyclic. They'll always lie on one circle, which is pretty neat. And it doesn't matter the angles of the original triangle too. See what I mean? We could change the angle right there, but those 4 points formed by those 3 orange points formed by the 3 circumcenters, and that last point right there will always be on a circle, believe it or not. Pretty neat and pretty wild. So the big question is, how do we formally prove that phenomenon true right there? Feel free to leave your thoughts and ideas in the comments.